What would you do if you had a time machine? Well, assuming you have a vague knowledge of sci-fi movies, you'll know the answer is don't step on the butterfly. Also, don't try to kill the guy that you're supposed to kill, but you'll never actually kill because you've already killed him. But regardless, I guess it doesn't really matter how many paradoxes you would create because, I mean, time travel is pretty much impossible. Or is it? Welcome to the Science of Sci-Fi. So, how do we obtain a time machine? Well, assuming Amazon is fresh out, you're going to have to understand temporal physics. Don't panic, it's just how time works. To begin, we need to think about light. Light is the fastest thing in the universe. 299,792,458 meters per second, always. The speed of light doesn't change no matter where you go, and nothing can go faster. So we have our universal speed limit, but this also gives us a time travel limit. To demonstrate, pretend this line is space, and this line is time. And this point, this is you, right here, right now. To get to another place in space, say about 300,000 kilometers away, light would take 1 second. This much time to get there. Same goes for this point, just keep plugging in the formula. Graph all those points and you get this 45-degree angle, same going in this direction. That means that if your friend's house is here, 300,000 kilometers away, you would take anywhere from 1 second to days to months or years to get there. But you could never be on this point, because there's no way you could move that fast. Everything outside this hourglass is off limits because of light. Even information can't travel fast enough to get there, we can't either. So here are your limits for time travel. Now back to your time machine. How do we get from
London, Earth, solar system
to say here, the moon on the 20th of July, 1969? The most popular way is via wormhole. Basically, you take 2 points of space-time, fold them together, and poke a hole through to get to the other end. Alternatively, you would create 2 points connected very close together on the sheet, and then as time progressed, one end of the wormhole would move with time until you decide to jump in. Suddenly, you're walking with Neil Armstrong. Now, theoretically, this is actually possible, as in there's no evidence that wormholes can't exist. You might come out dead, but it's perfectly possible. So great, start building your super secure time machine and get back to a time without school, right? Except there's a catch, besides actually creating a wormhole. If you did manage to create one right here, right now, you could only ever go back to right here, right now. So this entire past spectrum, nothing. Everywhere that's not, say, my living room at 9:30 a.m., you can't go there, even if I waited for 100 years and moved to England. I could only ever time travel back here. Now, there is another way to time travel if you're not so interested in the past. And for that, we thank Einstein, at least for the theory. Again, light speed is your speed limit, but as Charlie would say, if you could go
very, very nearly almost the speed of light.
Time warps for you. How? All the completely engaged students asked.
Another.
Say you're moving on a spaceship right above Earth, and your friend Amy is on the ground. If you have a mirror on the ground that is moving with you, and you shine a light down to the mirror, that light is going to bounce off the mirror and come back to you in a straight line. But for Amy the observer, because you and the mirror are moving, the light has to slant in order to catch up, coming back in a V shape. This line is longer than it seems to you, where the light is just going up and down. And since light speed is constant, but the distance is longer, the light must take a longer time for Amy than it did for you. Time travel-wise, your clock is actually moving slower than for your companion. And this is huge. This means that if you go extremely fast, just physically fast, you can actually speed time up, making your own time machine. A car that can go near light speed is just as effective as the TARDIS if you're looking for a fast trip into the future.
That's relativity, folks.
So in sum, yes, time travel is totally, theoretically plausible. Whether you can put this theory into reality or make a machine to do it for you and not die, that's another matter entirely. Time to do this. I totally drew this in the wrong order. Script, come on, we're done. Graph this point, and it happens to be at a right angle, because this is a very disproportionate graph. Yeah, but usually the light cone would be like very stretched out that way. Same goes for this one. People are 300,000 meters away.
Kilometers.
Kilometers away. I did this wrong, didn't I?
Probably.
Okay.